Good morning, students. Welcome back to Physics with Ashwini. So, as you can see on the board, today's topic is frame of reference. But before explaining that, I just want to tell you something. I just want you people to recollect a situation. Have you ever stepped into giant wheel? Or let us take a simple example. Like, have you ever entered into a lift? And have you noticed the changes in your body when the lift is moving up or when the lift is moving down? You feel a bit heavier, right, when the lift is moving up, and when the lift is moving downward you will feel lighter. Have you noticed this? And most of you might have experienced the giant wheel also, right? When the giant wheel is moving upward you will feel heavier, but the moment it starts coming down your body feels lighter and you feel like you are pushed away, isn't it? So, what is the reason behind this? Why do we feel heavier? Why do we feel lighter? Why don't we feel our actual weight all the time? So, the answer for that is our today's topic. So, first, let us see the topic and then you will understand the reasons behind these situations, like why our body feels heavier, why it feels lighter, etc. etc. So, you'll get all the answers for those situations once we complete our topic of today. So, without wasting the time, let us start our session. So, what is this frame of reference basically? It can be any object with respect to which the motion of other objects is decided. It is the object with respect to which the motion of other objects can be measured. In the sense, what? For suppose, let us imagine that you are traveling inside a bus. Okay, so this is you and this is myself who is taking the class. This is me and this is you. Okay, and there is a tree here. Okay, now imagine the bus is moving in forward direction. Now if I ask you a question, what is the state? Let us imagine you are the observer. Okay, so you are the observer and you are observing me. So what is the state of my body with respect to you? You are the observer. So bus is moving in forward direction and you are sitting beside me. You are the observer and I am the object under observation and we both are sitting side to each other. So what is my state of body with respect to you? I will be in rest position, right? I will be in rest. You just imagine the live example. You are traveling in the bus, you are seeing your side passengers. Bus is moving, but if you see the passengers, they don't feel like moving. They will be under rest only with respect to you, right? Now, if you see the tree here, let us take the tree under observation now. How do you feel about the tree? You feel like if the bus is moving forward, you feel like tree is moving backward. In reality, the tree is not moving, but you feel like the tree is moving backward. So, what is the reason behind this? Because you are taking different frames of references for deciding the state of a body. For example, if you take your co passenger as a frame of reference, it will be in rest. If you take the tree outside the bus as a frame of reference, in that case, you will be in motion. You just decide my state of body. You just decide my state of body. I will be in rest with respect to the bus. And I will be in motion with respect to the tree outside. Yes or no? You are the observer. You are observing the state of my body. And I have two different states. With respect to the bus, I'm in rest. With respect to the tree outside, I'm in motion. So why this is happening? You are deciding the state of same object, that is myself only. Observer is same. Object under consideration is same. But the object under consideration is having two states of bodies. Sometimes it is rest, sometimes it is motion. What is the reason? It's because you are changing the frame of reference. So with respect to bus, I'm in state of rest. With respect to tree outside the bus, I'm in state of motion. That means you are changing the object for reference. Now, tree is a frame of reference here, bus is a frame of reference with respect to which the motion of other objects, you can consider myself, other object, you can consider myself. So, you are deciding the motion of me with respect to bus, with respect to tree. So, I am the other object, and this bus and tree, they will be the frame of reference. So you got the clarity now. So frame of reference is simply an object with respect to which you will decide the motion of other objects. For example, if you take tree here, if you take tree as a frame of reference, with respect to tree, I am under motion. With respect to the bus, I am in rest. Got my point? Fine. So there are two categories of frames of reference, and this is important to understand. Initial frame of reference, inertial frame of reference and non-inertial frame of reference. What is this inertial frame of reference? Any frame which is at rest. That means this is not moving. Example, you can take the tree. Tree is not moving. So it's an inertial frame of reference. Or any frame which is moving with constant velocity. Constant velocity means change in velocity is zero. That means acceleration is also zero. So any frame of reference which is at rest or which is moving with constant velocity, it's an inertial frame of reference. Exactly opposite. A frame which is having some acceleration, that means its velocity is not constant. Non-inertial frame of reference, velocity is not constant. For example, you take the same scenario, bus example. This time consider the bus is not moving with constant acceleration. It is, when it is going to start, starting time, what happens? Speed increases. When it is going to stop, speed decreases. That means throughout the journey, the speed of the bus is not constant. Earlier here we considered, let us suppose the bus is moving with constant acceleration. But this time what are we doing? We are taking the bus example, but this time the speed of the bus is not constant. Imagine the bus is traveling in a traffic area. Its speed increases when traffic is cleared, or its speed decreases when there is heavy traffic. That means its speed is not constant. So if speed is not constant, what happens to acceleration? It won't be zero, because the speed is changing and acceleration is nothing but what? Rate of change of speed, right? So any frame which is having some acceleration, where its speed is not constant, what do we call it? We call it as a non-inertial frame of reference. What is the point of knowing this inertial frame and non-inertial frame? Actually, our topic is laws of motion and we were discussing the Newton's second law. So the point is here, NLM, that means Newton's laws of motion, they are valid for the observer in inertial frame. That means you take first law, second law, third law, they are valid only for an observer who is in inertial frame of reference. And if you take an observer in non-inertial frame, the Newton's laws are not valid. This is a key point. For this reason, we have to know which is inertial frame and which is non-inertial frame. If the speed of the reference frame of reference is constant, it is inertial frame. If the speed is not constant, then it means it's a non-inertial frame. Got my point? And third point is very important. Newton's laws are valid in inertial frame of reference and they are not valid in non-inertial frame of reference. Now here comes a question. See, if Newton's are Newton's laws are valid, then it is not much problem. Directly you can take the formulas, you can take the concept, you will simplify the problem. But what if it is a non-inertial frame of reference? Imagine this is a platform. Imagine a car on this platform. And imagine the car is moving forward with some acceleration a meter per second. Now, let us take the observer inside this car now. This is the observer. Now, if I ask you a question, where is the observer? Observer is in moving car because the car is moving forward with some acceleration. Observer is in moving car. Moving car having some acceleration. That means this is a non-inertial frame of reference. Now, this moving car is a non-inertial frame of reference. Why is it so? Because the frame of reference is having some acceleration, right? Now, observer is in non-inertial frame. He's in moving car. So what is the problem here? Newton's laws of motion, they are not valid. Then what do we do? How do we solve the problems in this scenario? So what we have to do is we just follow one tip. Star mark. What is the tip? So opposite to acceleration, what we have to do is we have to consider F is equals to ma, and this F is equals to ma. This is your pseudo force. See, pseudo means which is not real. What is the meaning of pseudo? It means it is not real force. If you see, in reality, the car is moving in forward direction. The force is actually in forward direction. What is the direction of force? Basically, F is ma, right? In the direction of acceleration, we will be having the force. But what are we doing here? In the opposite direction of A. That means in this direction, we are taking ma. In reality, it won't be in opposite direction. We are considering like that. So which is not real, that is pseudo. And why are we considering this pseudo force? Because the observer is in non-inertial frame of reference. So to make the laws of motion valid, we are considering this pseudo force. This is one more important point. Why are we considering this pseudo force? What is the reason? To make Newton's laws of motion valid for non-inertial frame of reference. Generally, they are not valid. To make them valid, to use them under, for non-inertial frame of reference, what do? We consider a pseudo force. And this pseudo force will be in opposite direction to acceleration of the body. I mean, acceleration of the frame of reference. So this is your pseudo force. We call it as FPS. Clear? Just consider pseudo force if it is a non-inertial frame of reference, and then apply the Newton's laws. If you don't take the pseudo force, Newton's laws of motion are not valid. Consider the pseudo force, then apply the Newton's laws of motion, you'll get the right answer. Clear with this? And there is an important case in this. You'll be asked some questions. Like there is a car, same car example again. Consider that it is moving forward with a meter per second square. You are the observer here. Now, where is the observer? Observer is inside the car. And how is this car? Car is moving forward with some acceleration. So what is car now? It's a non-inertial frame of reference because it is moving with some acceleration, right? Now imagine from the roof of the car, there is a bob which is suspended. Okay. Now imagine the car has started suddenly. The car started moving in forward direction suddenly. So what happens to this bob? Don't you think it will move backward? This happens for us, for even to us in the bus. Like imagine you are traveling in the bus. Driver suddenly applied the brakes. What happens to your body? You will lean forward. Or the driver suddenly starts the bus. Your body will lean backward. What is the reason? The reason is Newton's first law. Inertia of rest, inertia of motion. We have already covered this, right? Just refer to that video. So it's because of Newton's first law, the bob, moves backward. When the car suddenly starts moving forward, the bob moves backward. Now the concept is here, how much angular displacement the bob will make. This is the question. You have to find this theta. The car suddenly starts moving forward. Suddenly starts. That means the body will, move backward. How much, backward it will move? What is that angular displacement? So what do? We'll just use the concept of trigonometry. So apply tan theta. What is tan theta? Opposite side to theta by adjacent side to theta. What is opposite side to theta? This is the opposite side. This is the opposite side. And this is the adjacent side. And whereas this is the hypotenuse, right? We need opposite and adjacent. So take this. So what is opposite? Can I say it as pseudo force? Because core is a non-inertial frame of reference, and what is pseudo force here? M into A. And we are taking it in opposite direction of acceleration. A is forward, so pseudo force is backward. So opposite is nothing but this pseudo force. And what is the adjacent side? Don't you think it is the weight of the bob m into g? So just substitute here m into g. M cancel. So what will you get? A by g. So this is important. This conclusion is important. Remember this. Tan theta is equals to A by g. So A by g, you substitute the values, you'll get some answer. Okay, you'll get the answer of theta value. Sometimes they will ask you what is the acceleration of this non-inertial frame of reference. What is the acceleration of the car? So what you have to do? It is g tan theta. They'll ask, they will ask acceleration sometimes and they will ask theta sometimes. So you just remember this. This is enough. Tan theta is enough. A by g. Now we'll see this concept. Apparent weight of person. See, what is this apparent weight, which is not the true weight? What is the actual weight of a person? If the person mass is mkg, his weight will be acting downward, which will be equal to m into g. What is this apparent weight? Apparent weight is not the true weight. This is not the true. This is a fake weight, false weight. And why this arises? Because of non-inertial frame of reference. And to understand that, we'll consider a lift. See, what is this lift actually here? It's a non-inertial frame of reference. There are three cases. We'll consider the first case where lift is moving upward. So imagine this is the lift. It is moving upward with the acceleration a meter per second square. See, the concept is here, why don't the person feel his actual weight? Why is he feeling the apparent weight? That means some false weight. Why is it so? See, for suppose if I assume, let this be 5 kg. The person's mass is 5 kg. Then what will be the weight of the person? 50 newtons. When the lift is moving, the person will not this 50, will not feel this 50 newtons. Either he will feel more than this or lesser than this. Why is it so? What is the reason? Why don't he feel his actual weight when the lift is moving? It's because of the non-inertial frame of reference. Lift is a non-inertial frame of reference. That is a reason he will feel apparent weight. Whenever an observer is in non-inertial frame of reference, he don't feel his actual weight. He will feel some other weight, maybe more than his actual weight or maybe less than his actual weight. And what is that? Suppose if he is feeling 70 newtons, this is the true weight of the person 50. And what is this 70 newtons? This is the apparent weight. Why is it so? It's because of the lift, which is a non-inertial frame of reference. Why does he feel like that, etc., etc.? We'll see now. So for that, we are considering three cases. The first case is the lift moving upwards, moving upward with a acceleration. Now this is the person inside the lift. So what is the weight of the person? Tell me. Weight of the person. This is the mass of the person m kg. So weight will be equal to m into g. And what will be in the upward direction? Normal reaction. Now, what we have to do, the lift is a non-inertial frame of reference, and whenever there is a non-inertial frame of reference, opposite to the direction of A, what do? We consider pseudo force. And what is that pseudo force? M into A. Now, if you apply Newton's second law, F net is equals to ma. Here, F upward is nothing but F downward. So, mg plus ma. So, this is the actual weight of the person. And additionally, some ma weight is added. That is why when the lift is moving upward, the person feels heavier. Why does he feel heavier? This is the reason, because additionally ma weight is added. This is the additional weight that is being added. And what is the reason for this additional weight? Because of the pseudo force. And what is the reason for existence of pseudo force? It's because of non-inertial frame of reference. So what is the normal reaction when lift is moving upward? Mg and ma. Clear? Remember this formulas. Important. You will have some PYQs on this formula. Important. Now you understood. Like when the giant whale is, moving upward, or when the lift is moving upward, you feel heavier. What is the reason? Your actual weight is mg, and additionally you will have some ma weight. That is why you will feel heavier. And why that additional weight? It's because of non-inertial frame of reference. Now you just try to do the same I mean, you just try to apply the same concept for this case where the lift is moving downward. So same concept, lift is a non-inertial frame of reference. So what we have to do to apply the Newton's laws, we have to consider a pseudo force. But this time, how is the lift moving? Lift is moving downward with some acceleration. Now you are inside the lift. Same scenario, your mass is m kg. So downward, your weight m into g will act. Upward, normal reaction. And what is the direction of pseudo force now? Lift is moving downward, so opposite to it. So this is the direction of pseudo force. It is m into a. Now, if you apply Newton's second law, F net is equals to ma. That means F upward forces is equals to F downward forces. What will you get? N plus ma is equals to m into g. So, what is N now? Normal reaction. It is mg minus ma. See, this is your true weight. This is your actual weight. And this is the extra weight, ma. But that is being deleted from your true weight. So, this is the removed weight. So your actual weight is 50. MA, let us suppose it is 20. So 50 minus 20, you will feel 30. That means you are feeling lighter this time because some weight has been removed from your actual weight. So what is a normal reaction here? Your true weight minus some removed weight. So as your weight is decreasing here, how do you feel? You will feel lighter. You will feel lighter when the lift is moving downward. This is very similar, very, you can observe this in a clear cut way when you are in giant wheel, because I feel in giant wheel better compared to lift. In lift also we will feel, but giant wheel is a very good example. When you are, when the giant wheel is getting down, you will feel lighter. And I actually feel that I will be thrown away from the giant wheel. I will feel such lighter. What is the reason? Because giant wheel is a non-inertial frame of reference. And in non-inertial frame of reference, if it is moving downward, we feel lighter because some of the weight will be removed from our actual weight. So this is important formula. When lift is moving downward, what is a normal reaction? Mg minus Ma. And how do we feel? We feel lighter. These conclusions are important, remember. When lift is moving upward, we will feel heavier. Star point. And normal reaction is Mg plus Mb. When lift is moving downward, we feel lighter and normal reaction is Mg minus Mb. Now we'll see the third case. It's a general case. Lift is not moving. Most of the students do this mistake. Ma'am said lift is a non-inertial frame of reference. Better consider the example and also make sure whether that example falls under that category or not. Lift, when it is moving, then it's an example for non-inertial frame of reference. What is the third case here? Lift is not moving. That means it is in rest position. So lift is basically frame of reference, and this frame of reference is in rest. That means it's an inertial frame of reference. If you take the previous cases, lift is a frame of reference and that lift is actually moving. That's why it's non-inertial frame of reference. You got this difference? Simply lift is an example of non-inertial frame of reference. Wrong. Moving lift is an example for non-inertial frame of reference. And stationary lift is an example for inertial frame of reference. Got my point? Now lift is not moving. So let us consider this case. This is a lift not moving. That means acceleration is 0 meter per second square. And you are the observer inside the lift. So what will be the forces acting? Your mass is m kg. So downward your weight will be acting, which is m into g. And upward normal reaction. So apply Newton's second law of motion. F net is equals to ma. Upward forces is equals to downward forces. And there is no m into a because acceleration is 0, no pseudo force, nothing. So what is the normal reaction? Mg. That means you will feel your actual weight when the lift is not moving. When the lift is not moving, you will feel your actual weight. Got my point? Clear with this? Most of the students, they do feel like, ma'am, are you saying true? Is it true? If lift is not moving, okay, fine, actual weight. But when the lift is moving upward or downward, how does our weight change? I can't believe this. I don't believe this. Then you do a small experiment. Just take the weighing machine with you. Okay, or else instead of you being the observer, just take a small object, take a spring balance. You know the spring balance, right? Which is used for measuring the weight. So there will be a hook. You just attach a small object to this hook. Okay. And keep the setup of the spring balance inside the lift. Keep the spring balance inside the lift. Okay. Attach this. So this is your mass of mkg. Now you just see the readings in the spring balance. Spring balance will measure the weight, right? So just measure the weight of this mass mkg when the lift is not moving, when the lift is moving upward, when the lift is moving downward, then definitely you will be cleared with this concept. There will be a change in weight of this mass mkg. You have to measure the weight of this mass using the spring balance. So just attach the spring balance in the lift somewhere, somewhere to the top roof hook, something like that. You just keep the setup and just measure the weight of this mass. You will see the difference. Got my point? Now, so concept is done. We'll see some previous year questions. A person of mass 60 kg is inside a lift, okay, of mass 940 kg and presses the button on the control panel. Presses the button, that means lift starts moving. So it is moving upward. That means how will be the feeling? Heavier feeling. With an acceleration 1. So this is the lift moving upward with acceleration 1 meter per second square. Mass of the person is 60. And what is the mass of the lift itself? It is 940. So what is the total mass now? It is 60 plus 940. So it will be 1000 kg. This is the total mass. Now lift is moving upward. They are asking tension in the KVC. Tension is nothing but normal reaction only. So what is the normal reaction when lift is moving upward? It is mg plus ma. So take out m common, which is 1000. G is 10. Acceleration is 1. So it is 11 into 1000. This will be 11,000 newtons. Option C. Very simple. If you remember the formula, that is enough here. The mass of a lift is 2000. This is m. When the tension in the sense normal reaction, in the supporting cable is 28,000. Then it's acceleration. They are asking the acceleration of the lift. But to take the normal reaction formula, normal reaction is having two formulas, mg plus ma when the lift is moving upward and mg minus ma when the lift is moving downward. But which formula we have to consider? It was not mentioned. So see the options, upwards, upwards, downwards, downwards. That means you just have to verify the options one after the other. So let us take option A. Let us try to verify this option A. So let us consider lift is moving upward. So when lift is moving upward, what will be the normal reaction formula? It is mg plus ma. What is the normal reaction? It's nothing but tension, 28,000. M is 2000. G means 10. M is 2000. A we don't know. So simplify this, what will you get? So 28,000. This is 20,000. And this is 2000 A. So what will be 2000 A now? 28 minus 20, it will be 8000. So what is acceleration now? Three zeros cancel. 2 1 times and 2 4 times. So you'll get 4 meter per second square. That means you got 4 meter per second square as the acceleration when the lift is moving upward, right? So what is the right answer now? Right answer is option A. So we started to verify the options one by one and our answer is in the first option itself, 4 meter per second square when the lift is moving upward. So this is the right answer. Clear? Any difficulty? So this time they gave the normal reaction and they are just asking you to find the acceleration. We'll see one more question. A man weighs 80 kg. So this is the mass of the person. He stands on a weighing scale in a lift which is moving upwards. Okay. Lift is moving upward. That means you'll feel heavier. And what is N? Mg plus mu. You should recollect all these points with uniform acceleration. So it is moving up with acceleration 5 meter per second square. And what is the mass that is given? 80 kg. What we need to find? What would be the reading on the scale? So reading on the scale is nothing but what? We have to find the normal reaction. So what is normal reaction? Mg plus Ma. Take out M common, 80. G is 10, A is 5. So 15 into 80. 15 eights are 120, one more 0. So how much is the answer now? 1200 newtons. Option D. A monkey of mass 20 kg is holding a vertical rope. Fine. The rope will not break when a mass of 25 kg is suspended from it, but will break if the mass exceeds 25. What does it mean? Here, if there is a mass of 25 kg, it will not break. That means this is the maximum mass that is supported by this rope. So, what will be the maximum tension? T max is nothing but M into G. So, 25 into G. This is the maximum tension that can be supported by the cable. But what is the actual mass that is suspended here? Monkey mass is 20 kg. So, it will not break. Now, the rope will not break because this time to the rope, monkey is climbing on the rope and its mass is just 20 kg. So, it will not break because less than the maximum mass. No? Now, what is the maximum acceleration? What we need to find, what is the maximum acceleration with which the monkey can climb up? That means the monkey is moving upward. So upward in the sense what? What will be the normal reaction? Mg plus Ma. So here normal reaction is nothing but the tension in the rope. Okay. We have to find the acceleration along the rope. So what should we do? Just take N is equals to Mg plus Ma. This N is nothing but the tension itself. How much is the tension? It is 25 into G. What is the mass of the monkey? It is 20. 20G plus 20A. We don't know A. It is moving upward with A meter per second square. We don't know that. So simplify this. What will be 20A? 25 minus 20. It is 5G. And what is A now? So it is 5 1 times, 5 4 times. You will get G by 4. G is 10. So 10 divided into 4 parts. How much will you get? 2.5 meter per second square. So acceleration is option D. I hope you are clear with this problem. Maximum tension that can be supported is 25. That means they gave the normal reaction. You just have to find out the acceleration. See, it's the same formula. If you see all the previous year questions, 2003 and then 2003, 2009. So if you see 2011. So if you see all the previous year questions related to this lift problems, in all the cases, it was mostly lift is moving upward. So all the time it is N is equals to Mg plus Ma. But better you prepare the other two cases also. Lift is moving downward and when the lift is not moving. Okay. Again lift problem in 2002. Lift of mass 1000 kg which is moving with acceleration 1 in upward direction. So what is N again now since it is upward motion? Mg plus Ma. So this is the mass 1000 kg. This is the acceleration 1. The tension developed in the string. See, tension is nothing but here normal reaction. So what will you get? M is 1000, G is 10, acceleration 1. So 11 into 1000, this is 11,000 newtons. Option C. Very easy. The mass of 1 kg, this is the mass, is suspended by a thread. Fine. It is lifted up with an acceleration. It is lowered with an acceleration. That means two cases are there. First time moving upward, second time moving downward. This is first case and this is second case. When it is moving upward, what was the acceleration? 4.9. When it is moving downward also, what is the acceleration? 4.9. What we have to find? We have to find the ratio of the tensions. What is tension first of all? When it is moving upward, it is mg plus ma. When it is moving downward, mg minus ma. Let this be T1, let this be T2. So what will be the ratio now? If I ask you T1 by T2, m is common now. Take out it and cancel it. So you'll get a plus g by g minus a. G is how much? G value is 10. Here in decimals it is given, so you take 9.8 meter per second square. So 9.8 plus 4.9 by 9.8 minus 4.9. Shall we do one thing? What is 4.9 double? It's nothing but 9.8 now. So can I write this 9.8 as 4.9 plus 4.9? 4.9 plus 4.9. So what will be the numerator now? 3 times 4.9. What is denominator? It is 4.9. It gets cancelled. We'll get 3 by 1. So what is the answer? Option C. 3 is to 1. Clear? Done. So this is what for today. What did we discuss in today's class? Just recollect once. What have we done in today's class? We started with frame of reference. So frame of reference is basically an object with respect to which you can decide the state of body of other objects. Okay, and there are two categories, inertial frame and non-inertial frame. This is very important because if you know the kind of frame of reference, if you have clarity about that this is inertial frame, that is non-inertial frame, then you will get the clarity how to apply the Newton's laws in that case. If it is an inertial frame of reference, no need of pseudo force, directly apply the Newton's laws. If it is a non-inertial frame of reference, consider the pseudo force and then apply the Newton's laws. So how this Newton's laws apply in each case, you'll understand that only if you understand the type of reference, I mean type of frame of reference. So we have understood that, and also we have learned the concept of apparent weight, taking the lift as an example. And I hope you got the answers. Like why do we feel heavier when the frame of reference is moving upward, and why do we feel lighter like when the giant wheel is moving downward? I asked you these questions right in the beginning. I hope you got the answers for them. So you have understood why if person feels heavier, lighter, depending on the direction of acceleration of the lift. So that is what we have done, and also we have done some previous year questions, and most of them are based on lift moving upward. So remember one thing very important: motion is always relative, beta. You can't say that there is a standard motion of a body. A body will not be continuously at rest, or a body will not be continuously moving, or the same body will be under two states depending on the frame of reference. Like if you take person inside the bus, he is in rest with respect to co-passenger. He will be in motion with respect to tree outside. That means the same person is under two different states. Sometimes rest, sometimes motion. At the same time, the person is under two different states. So always remember motion is relative. Motion is always relative. Okay. So I hope you have understood the class. So next class, we'll discuss Newton's third law of motion, and also we'll do some PYQs related to that. So thank you so much. Have a nice day. Bye bye.